Hello, welcome back to the channel. Right, what you're going to watch here is a long time-lapse video of a three-phase fuseboard change. Me and my apprentice Lee, he's a guy in the high-vis jacket. We did this last summer. It was actually the first video I ever recorded. Hence a really poor picture quality. Actually, it's a time-lapse on a GoPro, so if you can see past the pretty poor image quality and bear to watch it, hopefully you'll find it a little bit interesting. So what we're doing at the moment, this is the existing setup. You can see a big beige main switch in the middle. There's a buzz bar chamber to the right of that with I think it was a 6x6 header trunking on top of that. And then you've got two small three-phase boards, a switch fuse in the middle of that, and then a couple of unused rotary isolators on the right. So at the moment we're in the process of stripping it all apart. You can see I'd stuck a load of white tape on the trunking. I quickly whip that up when I'm doing a job like this, cut it into little sections and use that to quickly put IDs on the cables we're pulling out. Now I've done a EICR on this job probably a month or two beforehand, so I got a good idea what all the circuits do anyway, so I'm not having to spend time tracing anything or trying to find out where it goes, because I already know all that. So all I've got to do is number up the cables as they're pulled out, and I can just refer to my electrical report that I did previously to work out what they did. So this is quite obviously an important stage of it, because if you don't get the cables ID'd properly as you put them out, then you're just going to make tons of work for yourself when you go to put it back together again. So yeah, we're ensuring that everything gets ID'd properly. Now I'm on the left here. I've got quite a few more circuits in my board. He's got all his out already. He's all in a bit of twin and earth at the top, which makes it easy to strip. Mine are all in singles. But yeah, everything's isolated. So Lee's looks like stripping out the towels now. He's undoing all the bushes that hold that board together. So it doesn't take that long. I think this is sped up, but it was maybe, I don't know, half hour to get it stripped out. But yeah, I'll let you watch it get stripped out, and then if it looks like something interesting is happening, I'll try and do a little bit of explaining. Now, I can't actually remember why it failed the EICR or why exactly why new boards were recommended. I think in this case it might have just been a mixture of such an accumulation of small issues. I think there was a lot of blanks missing from the fuse boards, no RCD protection, and I don't know if you know these old MEM1 boards, but RCBO saw them are incredibly difficult to source, and they don't make type A ones either. This industrial unit on the circuits that needed RCD protection, there would have been a lot of DC components on the circuits, so adding AC RCDs wouldn't have been an ideal scenario. There was also the single phase switch fuse, or was it three phase? The three phase switch fuse that was between the two three phase boards, that was of an age where I think it had asbestos flash guards in it, so that's another thing that's not ideal. I can't remember what else. I think ultimately there comes a point in a installation's lifetime where repairing it isn't necessarily the best option, and just an upgrade and a change is in need, and I think that's the case with this job here. You'll be able to see in a minute what I said about where the cables come into this board. This board was really difficult to see where the cables came in. The top of the board was quite packed and it did look like they were all coming through the trunking, but as you can see, they come into the back of it. I had looked into the office behind there. You know, I'd done that beforehand to check that, and nothing comes down the wall behind it. But it actually, there must have been I can't remember now. I think there might have been a little cavity in the wall, and they dropped down in there to get up to the offices up at high level. So I'd missed those when looking originally. So I'm just about to start doing some setting out now, ready for the new board to go up. I'm just setting out some level lines, a reference point for my trunking, and then also some reference points to put some supports up. Now the new fuse board was quite heavy. I didn't quite anticipate how much it would weigh actually pre-built, and it weighed quite a lot. So you see me cut some wooden blocks in a sec. I'll get them cut up, get them screwed to the wall, and use it as a way of holding the board up. So the board's about to come in now. In a minute. Come on. Come on, board, where are you? Don't do this to me. There is a board coming, I swear. Maybe in a minute. Come on. There we go. New fuse board. So that's a board. That's all built up and ready to go. So I suppose I should take a little minute here to explain why we've just lifted a pre-made fuse board into place. So we built the board off-site, pre-assembled the fuse board, the junction boxes, all of the trunking, with some careful measuring beforehand and some setting out. It wasn't that difficult to do, and you'll see soon when the lids come off of the boards as well that I also pre-wired it, so all the cabling is already in place from the fuse board to both junction boxes. So all I've got to do is connect up the old circuits to them junction boxes, and everything is done. So I had actually filmed the making of the board, but all the footage accidentally got deleted. All I've got is some photos, which is what you're seeing now. But yeah, so that's what was done. We'll get back to the video now, and you can finish watching it being installed. I've got the junction boxes in the right place, which was nice. And yeah, now it's just a case of getting that, well, not just screwed to the wall. There's a little bit of height adjustment to do to get it perfect, because that, you can see me, you see me just then working with the elbow on that bit of trunking that comes down. I can't do anything about that bit of trunking. That kind of ends where it ends. So everything's got to be assembled so that it lines up with that. So I have a new bit of trunking coming across, going across there, and then some galv bushes and couplings go in as well. You'll see that in a minute. So that's out of the way. I think I'll get the bit of trunking cut up now to go in. Just getting a main earthing block on the main earth, funnily enough. Now that wouldn't have been long enough to get to the new board, and obviously we can't cut into the service head to extend it. So I put an earth block in there to give me something to connect to. Going back up and working on the trunking now. Now I'm having to trim the little bit off next to it. That's a piece of plastic trunking. There wasn't really a lot I could do about that. It'd be quite nice to have replaced everything, but ultimately the job wasn't replacing and rewiring the whole of the building. It was just changing the boards. So it's nice to do everything from new, but some bits you've just got to work with what's there sometimes. So the plastic trunking stayed in, and I just set things up so that it could run into the new bit of metal trunking that I'm installing. You see me putting a few galv couplers in there, starting to set things out. There's all the new cabling in there. Now those junction boxes, they've got like a bank of DIN rail terminals in each one. Box on the left, box on the right. They've got, I can't remember what was in them now, to be honest. Maybe, you know, half of the circuits in one, half in the other. They're all ID'd up and marked with little cable identifiers. Is that what you call them? I'm not sure what they're called. The little plastic bits that slide over the cables with numbers on them. Just about to drill the rear entry holes in the left-hand junction box now. I'll sleeve them with a galv bush and lock ring on each one. I'm also having to gun them all out a bit just to get the holes exactly where they need to be. inconveniently, the hole they made in the wall probably 40 years ago didn't quite line up with the holes that I just drilled in my box. Looks like they didn't think ahead sufficiently. Lee's getting the trunking screwed and drilled to the wall now, so that's going to support itself in a minute. I'm just marking up the top of the junction box for my 𝐥𝐢𝐤𝐞 couplers now, getting the holes for them drilled. I've done the same in a minute on the piece of trunking that was there as well, and then that can all just be bolted together and it'll be ready to go. Lee's job now is to get the grid switch reinstalled with refitting the same grid switch that was there before. So he's going to get that all drilled up onto the wall and kind of first fix for me. He does that with the grid switch, any sockets that are going on. Also reconnect any bits of conduit or trunking here and there that need to be joined onto the new trunking that we fitted. I'm just getting the towels in now into the main switch. Lee's got the back box up for the light switch bank. He's refitting one of the sockets that was taken out. We're getting that back in now. So my towels are going in, 3 phases and neutral. There's a new main earth going in as well. They're just fitted into the bottom of the board with a big stuffing gland. I think it was a 50mm stuffing gland in there, pinched up tight. That holds them nicely in place, and they can just sweep down and around back into the meter on this job once they're ready to be connected back up. Just getting it dressed into place. Right, I'm just getting the socket wired up now. I'd left the cables for that just wrapped up in the trunking when we pre-built it, because I knew there was a socket going back in there somewhere. So that's going in there. Lee's just putting a joint box in now for a circuit that needs extending. The cabling for there wasn't long enough to reach the board, so just up above there in the trunking, the cabling for that junction box is wrapped up. So Lee's going to get that box on and a little bit of tubing, and then we can drop the cables down in there and use that as an extension box. And I'm on that top right junction box now, just starting to connect them circuits into the DIN rail terminals in there. Right, I've got that top junction box wired now. I think that's pretty much done. Lee's got the bit of tubing and he's just about to drop the cables down to that junction box. He's just drilling a hole in the side of it. You might not have seen it there. That's to put a little earthing bolt in so that the metal box is bonded. I'm now going to join those with, what do I use for that? I can't remember now. Probably some through crimps. Was it through crimps? Yeah, through crimps. Or was it through crimps? Damn it, I can't see. It's not good. It's too far away. It was through crimps. I remembered. Done a little bit of testing now. Doing my ZE testing on the incomer before the cover plate goes over the main switch. So I'm getting those noted and written back down again. Lee's about to join the what does that go to? That's the main, what do you call it? What's the technical term? The main protective bond to the water. He's getting that joined up now. I'm wiring up now this is a fuse spur for the, what was it for? This is for the outdoor lighting of the building. So it was fed via a power circuit before and fused down to 3 amp, you know, to give it the right overcurrent protection. Lee's just bent the tube to get the earth cable through. Getting that set out now. probably get his 20mm hole drilled in the top of the trunking in a minute. Fix that on with a female adapter and bush. I'm getting to work on the left-hand junction box now. Now this one was a bit more difficult. All these circuits in here, well not all of them, but the majority of them were in singles. And none of the neutrals and earths in the original board were well matched up, so it was quite a job to get some of the circuits properly identified. Lee's now struggling to get the 10mm earth through that bend, I believe. Yeah, he can't get it through there. I'll give him a little tip in a minute and he gets quite excited. Tell him to put a little bit of lubrication on it. He's not used to using lubrication for something as simple as putting a cable down a bit of tube. I think he uses lubrication for something else, but he gets to grips with it quite quick. See, yeah, Lee knows how to use a bit of lube. This junction box takes quite a while to wire, and even on time lapse it goes on for quite some time, so I'm not going to show all of this. Firstly, because I can't think of anything interesting to say over it, and it just goes on and on and on. So I'm gonna cut some of this out and skip ahead. Suffice to say, it got done okay with a little bit of unconventional cable tracing methods. I managed to get, you know, all of my lives and neutrals identified and put away as I needed to. So I'm having a break from the junction box, getting the grid switch bank wired back up now. I'd installed a little bit of tube between the 2x2 trunking and the 4x4 trunking, just to the left of the junction box that you can see. That allowed me to drop my cables down, straight down into the switch. I don't think they were long enough to actually run through that junction box. They were quite tight, so I got them down that way and back into there. That white box that you can see to the right of the new 3-phase board, that houses the surge device. It's got a 3-phase surge protection in it, in case you're wondering. Right, just putting the earth away that goes to the water, getting that put in the board. I think everything's almost ready to power up now. There's still some cables floating down on the left hand side. Most of them are earths, and it's almost impossible for me to identify where they all went. What I've got a load of neutrals there as well. They're also hard to identify. It's probably not the ideal way of doing it, but I've powered some of the circuits up, you know, just connected the live, and then seeing which floating neutrals then became live. It's not really a recognised way of identifying circuits, but sometimes you just got to do what you've got to do when you're trying to find out what things do, you know, and you haven't got the option of following every cable around the building. Ceiling height of this place was about 7 metres, and these cables all went up and around to high level equipment. So there was no way of getting up there and getting to the end of the circuit and, you know, and identifying them that way. Just bringing my bonds to the steel gas, and there was another one there as well. I can't quite remember what that went to. They weren't long enough to reach the new board, and I also didn't want to put I didn't really want to join them anywhere, so I put a single pole Henley block where them cables come out, they met that elbow. I'll put a Henley block there in a minute, you'll see, and I'm just using that as a way of extending them. I know that technically they should be unbroken all the way back to the board, but some things aren't ideal on an older install, and you do what you have to do with it. If it was a new installation, you certainly wouldn't extend them, but you know, on a board change like this, I'm not too worried about it really. It was all suitably labelled up afterwards and quite clear what they all done. We're just coming to the end of the first day on the job now. I think it's probably, I don't know, maybe around about 4 in the afternoon. There was no way the job was going to get finished this day, so it was time to pack up, get ready to go, and then I'll come back on my own the following day just to wrap up things like labelling up, final testing, and just a few other bits and pieces. So just getting those earths put away there, covers on the boards. Even though the building's empty, you never know if someone's going to come in or not. So yeah, little final touches for the first day, and then I'm back the following day. So this is the following day. This is early on a Sunday morning. So I'm back to carry on with the bits that got to be done. Now this board's been, up until the point of installing it, it's been rattling around in the back of the van. It's been carried here and there. So I'm just doing the torque settings up on all the breakers. If you look on your MCBs, RCBOs, and in the manufacturer's literature that comes with each board, all the terminals should have a specific torque setting that you need to do them up to. It's surprising, you get used to doing things up hand tight, but sometimes the torque setting needed is a bit harder than you think you might be doing it by hand. So it is good practice to be doing this, and you should be doing it anyway. It can seem a bit of a chore once you've done the second fixing and finished the board, but it doesn't really take that long to do. So I've got a few random earths here that I couldn't identify. There were 6 mils, I think. They didn't belong to any particular circuit. They might have just been old supplementary bonds to somewhere, but I've labelled them up in the board and just put them away. So try and ignore the absolutely awful camera footage here, but this is just a little close up of the junction boxes and what was done there. So there's that one. Not quite Steven Spielberg. That shows my age, doesn't it? That reference. Crikey. I think this is actually giving me motion sickness. I do apologise. This is worse than I imagined. If anyone can let me know what the issue is here, other than me and the camera I was using, I'll be happy to know. That's better. No more moving camera. So that was the little neutral covers going on there. So what am I doing now? Getting the long lead out. Must be just confirming that my main protective bonds are continuous. So this isn't brilliant footage, unfortunately. There's one of me connecting there, and then you're not going to see me wandering around the building. But I'm now going where am I going? I'm going to the water main at the moment just to check that it's connected that end. Got a little safety electrical connection, do not remove ID on that junction box I put in, and then sealing up that hole with some CT1, just so that the IP protection of the trunking is retained as good as possible. Right, on to a bit of live testing, doing my RCBO testing now. I'll do each one at the board, doing them on ×1 ×5, half time settings as well. It's a bit of a tedious job doing the RCDs, isn't it? Time consuming, but you got to do it. A bit hard to make RCD testing sound interesting, isn't it? It's not the most exciting of jobs. With labels going on, I like to make them, knock them up in my office. I like to do a nice little laminated ball chart to go on those. You can write a lot more on there. It looks neater, looks tidier. It's certainly better than handwriting, and it looks neater than the label printer as well, I think. It's no good if you're doing the board and not coming back to it, but if I know I'm coming back to a job, then I'll always do that and label them up that way. Couple of little warning stickers on the junction boxes. The yellow ones are danger, 400 volts, and then the white label just says what it does, basically, cable extension box or words to that effect. I like to whack a circuit ID on everything I've done as well. So on the socket there, on that little junction box to the right, you know, there's the fuseboard reference, the phase and the circuit reference as well. And lastly, the next inspection date sticker went on then. So unfortunately, you've got another vomit inducing moving video here now. I think it's a little bit more stable than the other one. I suppose this is as good a time as any to ask you to click the like button if you like what you just watched. Subscribe as well, that'd be brilliant. Leave a comment on anything, you know, if you liked it, if you didn't like it. I know electricians are really fussy people, so I expect a load of slagging off from this. So yeah, get stuck in, write it down there. I'm willing to take it. Hopefully though, you know, you just liked it and didn't think it was a load of shit, but we'll see.